Hi, welcome to another edition of Design Spark Ask the Expert. Today we're going to be talking about motor starting with Chris Ward from Siemens. And today we're going to discuss the right solution for starting three-phase asynchronous motors. Hi, Chris. Welcome to Design Spark. Would you like to introduce yourself?
Hi everybody. So as Greg just kindly introduced me, I'm one of the product managers for Siemens and my responsibility is switchgear for motors.
Great. So, Chris, I guess the first question is then, what are three-phase asynchronous motors?
So they can be called different things, but three-phase asynchronous motors is one of the terms that's used. I prefer the term induction motors, and that's probably more commonly used in the UK. So an induction motor is an AC electric motor, and that's where the electric current is needed to produce torque. So this is done with electromagnetic induction. So the idea is that there's two different types of induction motor. There's a squirrel cage type and then there's a wound type. So the three-phase squirrel cage induction motors are the ones which are more widely used in applications on industrial drives. So these motors are frequently used in, say, 90% of the applications worldwide. So that's because they're self-starting, they're more reliable, they're more economical, but also they're extremely robust as well.
Okay, so we're just talking about the applications then. So what type of applications are best suited for this motor type?
So as I mentioned before, so the induction motors are the leading energy consumers in industrial applications worldwide. And Siemens has done some research into what applications are the most popular. And what they've done is they've found out that up to 80% of applications worldwide sit in this band. And those five elements are pumping, ventilating, compressing, conveying, and also processing applications. But each of those individual applications, they all present differing challenges, and there's a whole range of possible solutions which you can have for those differing challenges.
Okay, so when we were talking, we mentioned the right starting method. So, what are the starting methods that we have for these types of motors? If you can just elaborate on those a little bit more.
Okay, yeah, that's a great question. So we normally have, I would say we put them into four different categories. So we have what's known as a direct online starter. So that's a physical mechanical switch. And that normally draws quite a high amount of current and torque during the startup of the motor. So that can have a negative impact on the motor itself, but also on the machine. Then we have a reversing pair. A reversing pair is similar to that, so that's also a mechanical solution. It's a physical switch, but it's two contactor switches which are in combination with one another. And the idea is that one sends the motor in one direction and the other sends the other in the reversing direction. So clockwise and counterclockwise motions. But because again, it's also a physical switch, that also draws a high amount of current and a high amount of torque during the starting procedure, which, similar to the direct online starter, has a negative impact on the motor and the machine. Then there's this star delta starter. So star delta starters are similar to the direct online start and reverse, as they're also a mechanical solution. So they're also physical switches. So there's three contactors in combination with each other. And what it does is it provides like a voltage step. So it switches from star to delta at around about 70 to 80% of the speed to slowly increment the voltage up to the full line voltage.
Yeah.
So the idea behind that is you get a reduced starting current and a reduced starting torque. And then we have the soft starters. So soft starters work through this voltage ramp. So the idea is that you have a starting voltage, say, of 200 volts, and then you set a potentiometer on the front of the device, which would then take you up to the full line voltage. So you're slowly ramping that voltage up. So that's actually an electromechanical solution. And the idea with that is it produces a lower starting current and a lower starting torque than the other three methods which I just mentioned. And then the final one is the variable speed drive, so the VSD solution. So the VSD is completely electronic, and that works through it manipulates the speed through frequency control, and that basically completely eradicates the problem of reducing the starting current and the starting torque as well.
Okay,
So
so
they're the main switching elements.
so you've explained to us then some of the subtle differences, and if we go from maybe the first one, direct online, through to your VSD, it sounds like each stage, is it reducing the impact of the starting, for example? So if we're looking for the right solution for starting and stopping a motor, why
Mhm.
is that important?
Okay, yeah, so it all depends on what the customer or the end user or whoever's selecting these devices actually wants out of the device. And there's so many different considerations which customers need to consider before they actually select a device, which they might not even be aware of. So what they need to be aware of, what can dictate what type of device they use it, are things like the application. So say, for example, if you have an application which is, say, for example, a pump, you might be able to use a direct online starter for that. But say, for example, if you was to use a crusher, which is an extremely arduous application, then that might eliminate that type of switching method like a direct online starter. And you might have to use something like a soft starter or a VSD. So the application can sometimes dictate which type of device that you use. The power range can also dictate which type of switching method that you use. So, say for example, you wouldn't be able to use a direct online starter at 500 kilowatts because the range that we would typically suggest for that's around about 15. You might have to go down the route of a soft starter or a VSD for something so heavy duty.
Yeah.
Some of the other things that you might have to consider are things like protection. So if you want integrated short circuit protection, or you want a built-in overload, or you want those devices separately. So that can also dictate what type of switching method that you want to use. And then there's things like integrated safety. So you can use safety through a mechanical auxiliary switch, which is bolted onto the side of a device. You can have safety over a network, or you can even have safety integrated into some of our technology as well. So again, that can dictate which type of device that you might want to use. Then there's things like communication capabilities, as I'm sure you're aware with this digitalization concept that we're offering at the moment, and everybody seems to be talking about it. Things need to communicate with one another, and the idea is that now we want devices to communicate over Profinet, Ethernet, Modbus, things like that. So that can also dictate what type of device you want.
Right.
Similarly, monitoring capabilities is another one. So if the customer wants visibility of how their motor's performing, so that they can optimize their plant's performance or start to predict maintenance, then they need a device that's going to be intelligent and has that capabilities. So that'll also be another thing that they need to consider. Similarly, another thing that's quite important to customers is the cost. So, which is the most cost-effective solution that can have an impact. The size of the device, in space saving inside the cabinet where space is restricted. If somebody's doing a retrofit where there's limited space, they might want to go for the smaller unit. Sometimes people want a quick and easy setup. So the configuration of the system, how complex is the system to set up initially? Also, how easy is it to maintain those devices? And also, is energy saving important to the customer? So all these different aspects, which I've just flitted over, are all things that the customer should be looking at before they buy the device, because if they get those things incorrect, then further down the line, it's going to cost them in the long run.
Yeah. So I guess what you're starting to describe there is that there are some advantages and disadvantages for each of those starting methods. Is that right?
That's absolutely spot on. Yeah, you're absolutely spot on with that. So what I've tried to do here is I've tried to categorize it and put them in rankings. So like a direct online starter and a reverser, I've put those two together because they're both physical switches and they have the same type of startup. And then we have the Star Delta, the soft starters, and the VSDs. So say, for example, if a customer was looking at speed control, the only option which they would have for that would be to use the variable speed drive. If they wanted fixed speed, then they could use a direct online starter or a reverser, Star Delta starter or a soft starter. So that would dictate the application. So if the customer wants variable speed, it would be a VSD. If not, then they could use the other three options, which I just mentioned. Similarly, power's another one. So what we would normally suggest is if you go in at up to 15 kilowatts, direct online starter or a reversers, possibly a good solution for you. If you're looking at going higher than that, then the Star Deltas go up to 500 kilowatts. Then we have soft starters up to 1.2 megawatts. And then we have the variable speed drives, which are more universal. Then when I've tried to look at the current spikes as well. So we mentioned before and we talked about it. So current spikes can have implications on the motor, but it can also have implications on the machine. So a DOL and a reverser, they draw like up to 9 times the rated current during the startup. So they have an extremely high current spike.
Yeah.
Star Deltas work on switching from star to delta. So they have a medium current spike. Soft starters work on voltage control through a voltage ramp, so they have quite a low current spike. And then the VSDs are similar, they have a fairly low current spike as well. If you're looking at space saving inside of the cabinet, the DOL and the reversers are the best solution for that. So they're the ones that take up the least space. Star Delta starters comprise of 3 contactors, so they can take up quite a large space inside of the cabinet. Soft starters are more of a middle of the road space saving inside of your cabinet. And then the VSDs are similar to the Star Deltas. They can be quite a large size. In terms of the impact that you have on the mechanical load, the current spike and the mechanical load sort of work in tandem. So if the impact that the DOL and the reverser have on the mechanical load is quite high, Star Delta is, we would say it was medium. And then when you're looking at the soft starters and the VSDs, we say the impact on the machine is relatively low. In terms of the communications on the devices, we say that for the DOL and the reverser, you are limited to the type of communications that you can have on those devices and the Star Delta. So the only communication that you can have on those devices is through IO links. So you are limited. But if you was looking at something like Ethernet, Modbus, Profibus, then you'd have to use a soft starter or a VSD to use those types of communication protocols. In terms of safety, if we was looking at that, if the customer was or the end user was happy with looking at safety and using just an auxiliary switch to switch the safety circuit in and out, then you could use the physical switches. So you could use a DOL and a reverser or a Star Delta starter. If they were looking at a little bit more than that and they wanted, say, integrated safety or they wanted safety over a network, then you'd be looking at a soft starter solution or a variable speed drive.
Yeah.
Another key aspect would be the cost of the application and the setup. So the DOL and the reversers, although they present a high impact on the machine and the motor, they're the lowest cost option. So they're still an extremely popular item to select. Star Delta starters are more of a medium cost, as are the soft starters. And then the variable speed drive comes in at quite a high cost, but that's more of the high-end solution.
Yeah, so there are quite a number of factors there to consider for starting motors. So if we take some of the examples that you mentioned there about impact load for DOL as against maybe smooth transition if you're using a VSD, obviously one will be a cheaper option, one will be a more expensive option, but it really does depend on probably the overall cost of running that application and also making sure that you want to limit maybe any stress factors, for example. So there are definitely, a lot of considerations that a user needs to make before he starts to implement a motor start and procedure. What is it that you've done to improve that customer experience?
So one of the things that we've tried to do is we've tried to provide the customer with everything that they're going to need to make that selection for themselves. So we've tried to do that by providing them with a white paper which breaks down all the advantages and disadvantages of each of the switching methods and presented to them how to make the selection for themselves. But we've also created this automated process which guides people through to the right solution as well.
Okay, that's really interesting. You're talking about obviously the white paper, which is great, people to research, but an automated solution sounds really interesting. Is it possible that you could demonstrate that for me?
Oh, absolutely, yes. I've actually provided a video for this, so we'll just jump straight into that now and it'll guide us through what the benefits and features are and how to use that.
So in this demonstration, I wanted to show you the format of our new web page and the contents. So hopefully you'll find the video useful. So firstly, how do you gain access to this platform? So if you just follow the link below the video, it'll take you straight through to the RS and Siemens collaboration on the title, the right solution for starting three-phase asynchronous motors, or induction motors as they're more commonly known. So there's a host of information on the web page which will assist anyone in switching method selections based on their priorities. So we've tried to align this with what our customers actually value, and every customer's application is different and what they value is different. So whether that's keeping your costs down to a minimum or going into predictive maintenance and energy saving. So the most important priority for us is guiding you through to the correct solution to which you will gain the most value for your application. Brief introduction into what the page is about. If we scroll down from there, we've got a little section which explains how to find the best solution for each motor starting application. In here it vaguely talks about the applications for induction motors and the different type of switching methods. If we scroll down a little further here, we've also got a really great video. So it says there are a lot of options to start a motor, but which ones to use. And if you're interested in knowing more about that, Andreas Thomas encapsulates that perfectly within that video. If you scroll down here, there's another really important part of the web page to look at, which is IE3 and IE4 ready for the Sirius switchgear. So we've got a section which is entirely based on IE3 and IE4 motors and the Sirius range and how it aligns with the new duty that's just been released, AC3E. So not only is it a cost-effective solution, but it helps in reducing the ever more present reduction in CO2 levels. And in this section, if you click on that link, it'll take you through and it'll explain how it achieves that. Another great feature which we've got is all the different switching methods that you can see here. If you click on those links, it'll take you through to each of the switching methods, but it'll also provide you with the benefits and features and some case studies as to where these devices can be used. So the main part of this explanation and demonstration is to guide people with selecting the correct unit, and we have two ways in which we can offer assistance with that. So the first, if we scroll back up to the top of the page, as you can see here, there's this request a white paper, and that can be downloaded. So the document provides a good insight into each switching method and how it compares to the others, so you can draw your own conclusion on which technology is most suitable for your application. And the second option, if we scroll down the page again, you've got this link here which is decision guide for motor starts. So this is personally my favorite option. So this is the automated process which guides the user through a series of questions to find an appropriate selection. So all we have to do is click the link, and we can start a live example. So we'll run through 2 examples, a low-end solution and a high-level solution for the proof of concept to prove that the automated solution's a viable option. So now we've clicked on the decision guide for motor starting. As you can see here, this is the page where we start the automated process, because if we scroll down the page here, it provides us with our first question that we've got to answer. So what we can do is we can decide here what type of application that we have. So from this it says, do we have a pump, fan or compressor? Is it moving or conveying, or is it processing materials? So if we click on pumps and fans and compressors, it'll then prompt us to our next question. What's the speed? Is it a constant speed application, or is it a changing speed application? So we'll say, for instance, we'll class this as a constant speed, and we'll say the power rating of the motor is 55 kilowatts by bringing this bar up. Then we'll click next, and then it's drilling down a little bit further into what type of application we have. So at the start it asked us very vaguely what type of application that we had. This is drilling down into it a little bit deeper. So what type of pump facility do we have? Is it a fan or is it a compressor? So we'll say it's a wastewater pump. And from here it then will take you through to our results from the information which we've input. So as you can see here, there's a cost-effective solution and then there's a more optimal solution. So the cost optimal solution is the mechanical solution, the 3RA2 load feeder. So on here it provides us with a focal point to how to configure a device. So that'll take us through to the TIA selection tool and guide us through building up the part number. And then there's also a section here on more information which will show us a little bit more about that technology and the benefits and features it can bring to the table. On this other solution here, this is the more advanced solution, so this is the hybrid solution. Here it's the Sirius Soft Starter 3RW55 high feature range. Again, similar to the load feeder, we've got a configure now section which takes us through to the appropriate section in the TIA selection tool. And also here we've got more information on that unit. So once we've decided on which type of device we want to use, we can then go on to configure a device. But now we'll have a little bit of a look at another option. So we can click restart and say, for example, we can go through another application and we'll say that this one is perhaps processing materials. We'll say it's a variable speed application, so it's constantly changing. And we'll say it's a really powerful motor, so we'll say it's 560 kilowatts. And then we can click next, and then as you can see here it'll provide us with our results. So there's only one solution for a variable speed application, and that's a VSD. So that's the optimal solution. It'll tell us what range to use. So it's a frequency converter and the range is a G130. Similar to the other 2 ranges, it'll tell us how to configure the device and where to configure it if we click this port here. And if we go to this section here, more information, it'll take us to more information of the benefits that the G130 can bring. So I really hope you found the video useful and insightful, and please feel free to leave any comments afterwards. Thank you.
Chris, that was a really great video there. Really kind of took a lot of the decision making process and like you say, automated it. So why is it you decided to create that platform?
That's a good question. So the main reason why we've done this is because we've had a look at our customer experience and how they were selecting their switching methods previously, and thought, actually, we've got some reasons here. We've got a hole in our customer experience. We've got all these great products that have been recently innovated, but have people got all the information that they need in one place to guide them through to the correct selection? And the answer to that was no, we don't. So the idea was that we've tried to make that a lot easier for people by housing all that information together, creating the automated process, and guide people through that selecting and switching a motor. And show them how to improve in terms of how they can save on the time and the cost. I mean, when we're looking at time saving, we're looking at time savings on the selecting the device. So if they're using this automated process, you know, the time that it takes to use that is minutes. Whereas if they were looking at websites, trawling through user manuals and things like that, it's quite time consuming. Similarly, it saves them in costs in the long run, because if they select a device and it doesn't actually do what they want it to do from the blueprint, from what we was discussing before on, you know, what are the fundamentals that our customer really wants from the switching methods, and they get that bit wrong right at the start, and it's going to cause them problems further down the line. So the main objective really is to provide our customers with the right tools to make the appropriate selections.
Great. And what I really liked about the demonstration as well, it wasn't just one option. You gave in certain examples two options. There was a lower cost option and a higher cost option. So that was really that was something that I hadn't seen before, and you know, seeing that was great. So the customer still has, you know, a decision to make, but it's a decision based on application, which is really cool. So in terms of target audience, who are we talking about?
So this isn't really directed at anybody. It's anybody really that wants to learn about switchgear. You know, it's for anybody to use the platform really. So the target audience is open to all. So end users, OEMs, panel builders. You know, they're the types of people which will probably get the most out of using a tool of this nature, I would say.
Yeah. And Chris, just before we finish, I just want to revisit sort of like the main advantages of that platform. So you were talking about time saving, uh, getting to the right product at the end, the right solution at the end. Do you just want to maybe give a quick overview of what the advantages that you guys at Siemens see for using this platform?
Okay, super. Yes, of course. Yeah. So to summarize what we've just gone over, it's easy to find a suitable product for your application when you're going to use the tool. Also, you can do this more efficiently through using the automated process. So the platform provides you a good learning insight into the switch, all the various different switching technologies, and it doesn't discriminate against any. And the idea is that you don't have to go through trawling through websites, looking through user manuals to make your own assessments, because everything's enclosed onto this one platform now.
Great. And Chris, it's been really great talking to you today about MotorStart, and it's such a big topic. And I think, you know, in a short space of time, you've managed to convey quite a lot of useful information to users, to customers, but also demonstrating the platform, and obviously sharing your vast experience with us from Siemens has been great. And I hope we can talk to you again on Design Spark again real soon.
Oh, thanks very much, Greg. You've been a great host. Thank you.